Hello. Today we will continue some more multiple choice questions from the lesson permutations and combinations so that we will have enough practice. So the first question we are going to deal is total there are n books. N books in the sense this is the first, this is the second book, this is the third book, and so on. Like this, n books are there. And there are p copies of each. So the first book has p copies 1, 2, 3 up to p. Each has p copies. So 1, 2, 3 up to p copies. The third book also 1, 2, 3 up to p copies. And the nth book also 1, 2, 3 up to p copies. Now, the question is the number of ways you have to find in which a selection can be made from them. So, number of ways a selection can be made in this story. That is what you have to find. So, first of all, what you can see is if I take the first type of book, I'll take the first type of book. If I want, I will not make a selection at all. I will not select anything. If I want, I will select one book out of the P copies. I'm talking only about the first book. I'll select only one book out of the P copies. If I want, I will select two books. If I want, I will select three books. Or if I want, I will select all the P copies. That means total I have P plus 1 ways to select because I'm including the P copies as well as zero, no selection at all, I'm including. Similarly, the second book also can be selected in P plus 1 ways. The third book, which has P copies, can be selected in P plus 1 ways. And the nth book also can be selected in P plus 1 ways. So, how many P plus 1 ways are there? Do we have to multiply or do we have to add? That is the question. Suppose if I just select P plus 1 ways the first book, my work is not complete because I can select from the second book also. I can select from the third book also. So my work is not complete here. That means we will multiply. We will multiply P plus 1 n times. So P plus 1 power n ways. But there is a way where you will not select any book. Zero books you will select. Then that case you cannot count as number of ways. So that one case you will subtract. So the answer will be P plus 1 whole power n minus 1. Okay. Question number 2. I'm giving you the digits 1, 2, 3, 4, 3, 2, 1. Now, your work is to make numbers with these digits. And then you have to find number of numbers that can be formed. The condition is odd digits to be in odd places. That is the condition. So first of all, how many numbers you have? 1, 2, 3, 4, 5, 6, 7. So with these 7 numbers, if you make numbers taking all 1, 2, 3, 4, 5, 6, 7 digit numbers you will get. In these 7 digit numbers, what are the odd places? Odd places are first place, third place, fifth place, seventh place. So total 4 places are there for odd digits. So these are odd places. Odd places, total 4 are there. Now, what are the odd numbers you have? Odd digits. Instead of numbers, it is better to write digits. So, what are the odd digits available to you? How many I gave you? That you have to count. So, the odd digits are 1, 3, 3, 1. I gave you 1, 3, 3, 1. That means total 4 odd digits I gave you. So if I want to arrange these odd digits in odd places, how will I arrange? 4 numbers are there. Total 1, 2, 3, 4. 4 numbers are there. So 4 factorial. But ones are coming 2 times. One type, 2 things. So 2 factorial. And then threes are also coming 2 times. So another type, 2 things. So here also 2 factorial. So this is how you can arrange odd digits in odd places. But if you arrange just odd digits, your work is not over. So you have to multiply something else. What is that something else you are going to multiply? You are going to take the left of numbers. What are the left of numbers? They are even numbers. So what are the even numbers we have here? 2, 4, 2. And what are the even places we have here? This is the second place. This is the fourth place. This is the sixth place. We have total 3 places and 3 even numbers. In how many ways you can arrange? Because total 3 numbers are there. 3 factorial by 2 is coming 2 times. So 2 factorial. That's it. 4 is coming 1 time. So 1 factorial I need not write. So now my work is complete. So I can simplify this and write as 4 factorial means 4 into 3 into 2 factorial. So another 2 factorial. One more 2 factorial becomes 2. Then 3 factorial is, or I can write the other 2 factorial also same. And then multiply it to 3 factorial is 3 times 2 factorial. This 2 factorial I will write as 2. Why I wrote 2 factorial? Because I can cancel 2 factorial, 2 factorial. And then I can cancel 2 2's. So left is 2 into 3 into 3. That is total 18 ways I can form such numbers with the given condition. Let's go to question number 3. Total, there are 18 points in a plane. No 3 of them are collinear except 5 points which are collinear. Only 5 points are collinear. Now your question is number of straight lines formed. So because total there are 18 points, out of 18 you have to select 2 points, because when you select 2 points and you join them you get a straight line. So you have to select 2 points. But they said there are 5 points which are collinear. So if from these 5 points you select 2 points and make a line, or you select these 2 points and make a line, or you select these 2 points and make a line, or these 2 points, or these 2 points. On the whole, you are getting one line only, not different lines. So you have to subtract the cases where you are taking these 5 collinear points, and from these 5 collinear points you are selecting 2 points because you are getting a single line. So you are removing that. But once you remove it, you have to add one to it, because this one particular line which we got and which we have removed, that has to be counted. And so I will simplify this as: start with 18, take two numbers, divide by 2 factorial, minus start with 5, take two numbers, divide by 2, plus 1. So 2 nines, 2 twos. So first you have 9 into 17, that is 153, then minus 10 plus 1, that is 144 straight lines can be formed. Let's go to fourth question. Now, the question is the sum of proper divisors of the number 72. But remember, 1 and 72 are excluded. I will remove these brackets. So one condition is 1 and 72 are not to be counted. They are excluded. But one thing you see here, they are adding proper divisors, not normal, sum of proper divisors. So we will see first of all, what are the divisors of 72? That means 72 comes in which table and how? First of all, when you start with 172s, 1 times 72, 1 into 72. But you cannot include 1 and 72. So we will not take these divisors. Next table, 2 into 36, 72. Next, 3 table, 3 into 24, 72. Next, 4 table, 4 into 18, 72. In 5 table, you won't get 72. What about 6 table? 6 table, you get it. 6 into 12, 72. Next, 8 table, 8 into 9, 72. So these all are proper divisors of 72. Your work is you have to find the sum. So as per the question, you are finding 2 plus 3 plus 4 plus 6 plus 8 plus 9 plus 12 plus 18 plus 24 plus 36. When you have an easy method, you need not go for shortcut method. And so you will get 122 as the sum of proper divisors. Coming to question number 5. Now, let n be integer, any integer. And n is between 0 and 21. Now, I'm asking you, what is the minimum value of n factorial into 21 minus n factorial? That I'm asking. Actually, this problem, if you do in a long way, it will be difficult for you. So easy method is go for options and guess. The first option is 9 factorial into 12 factorial. B is 10 factorial into 11 factorial. C is 20 factorial. D is 21 factorial. Now, which of these options, when you put for n in this expression, that means if you see the first option, here n we will take 9. In B, n we will take 10. In C, what do you have to take n as? N is 1 factorial. In D, what will you take n as? N I will take 0 factorial. Just 0. That means in A option, n I am taking as 9. In B option, n is 10. In C option, n is 1. In D option, n is 0. So by guess, you have to find out which option will give you minimum value. So the main thing is we are finding the value of n factorial into 21 minus n factorial. Now suppose if you take the first option 9 factorial into 12 factorial. How will you write this? I will write 9 factorial into 12 factorial. I will write 12 into 11 factorial. Okay. So this 9 factorial into 12 into 11 factorial, obviously it will be greater than 9 factorial, 11 factorial. I will keep same. Instead of 12, I will keep 10. So if 12 is replaced by 10, suppose if, because 12 is greater, this will be greater than 10. And now 9 factorial into 10 into 11 factorial. I can write this as, I can combine 10 into 9 factorial and write 10 factorial and then 11 factorial. So actually I have doubt which one is minimum. I have doubt only for this and this. Why will I have doubt only for this and this? I will tell you that also. So which one is greater, which one is lesser, I have to find. That's why I started with 9 factorial into 12 factorial and I wrote like this. Then if I replace 12 by 10, obviously this will be greater than this. And so this is the greater one. Option A is the greater one. It can't be minimum. And this is the lesser one. There is a chance for this being minimum. Now, why we are not seeing 20 factorial and 21 factorial? Because if you take C, 20 factorial means 20 into 19 into 18 into 17 into 16 into 15 into 14 into 13 into 12 factorial. Obviously, if you see this number, it will be more than 9 factorial. This number will be more than 9 factorial. Because 9 factorial means what? 9, 8, 7, 6, 5, 4, 3, 2. See, 20 is more than 9. 19 is more than 8, 7 is more than, 18 is more than 7, 17 is more than 6, 16 is more than 5, 15 is more than 4, 14 is more than 3, 13 is more than 2. So on the whole, these are greater compared to 9 factorial. So this is greater than 9 factorial into 12 factorial. So I'm telling about 20 factorial. Obviously 21 factorial will be more. 21 factorial will be more than 20 factorial. And this 20 factorial which I wrote here, it is greater than 9 factorial into 12 factorial. And 9 factorial into 12 factorial is greater than 10 factorial into 11 factorial. So the minimum will be option B. So this is all by guessing method, because we can't do it in long way. Okay, next sum is, I am giving you a few digits, 3, 4, 5, 6. And I'm telling you repetition is not allowed. So when repetition is not allowed, I have to make total and find out total number of numbers which I make and which are greater than 100 and divisible by 5. That's my condition. So first of all, greater than 100 means they must be 3-digit numbers. Of course, because we are given 4-digit numbers, we can include 4-digit numbers also. All these numbers will be greater than 100. But then they must be divisible by 5. So the last digit must be 5. Then only they are divisible by 5. Okay, but now how many such numbers can be formed? That is the question. So how can you find out? We are fixing the 5 in the units place. We will not disturb it. So now how many places are there for us? Repetition is not allowed. So if I want to fill up here, I have how many numbers? After 5 has been taken, I have 3 digits. I will not write numbers actually. So after 5 is filling up, how many digits I have? I have 3 digits. And how many places I have to fill up? 2 places. So that I can arrange and fill up and do all that in 3P2 ways. But my work is not complete. So I have to multiply. Here already I have taken 5 and it got occupied. I have 3 digits here also and I have 3 places. So I can fill it up in 3P3 ways. Now the total ways I can do this work is 3P2 into 3P3. What is 3P2? Start with 3, take 2 numbers. What is 3P3? It is 3 factorial. So I will take the first one, 6 plus 6. Total 12 ways it is possible. Now, why am I adding? Why am not multiplying? So first when I do or make 3-digit numbers, that is one way of making the numbers. After that, I can make 4-digit numbers also. That is the other way. So total, I am adding them. Okay. Next question. Suppose there are total 7 persons and they are to be seated at a round table. The question is, all the 7 persons have no same neighbors. When we are arranging, all the 7 persons will not have same neighbors in two arrangements. So what do they mean by this? How many arrangements can be made? Number of arrangements, such arrangements we have to find. So when I'm saying in two arrangements, they should not have the same neighbors. What does that mean? Suppose there is a round table. This is person 1. This is person 2, person 3, person 4, person 5, person 6, person 7. So when I am counting clockwise arrangement, that is one arrangement, one way. But if I keep them like this only, and if I count the anti-clockwise arrangement, then you see P1 will be having the same neighbors, P7 will be having the same neighbors, P6 will be having the same neighbors. In both the arrangements, we will be having same neighbors, but that same neighbors should not be taken. That means we will take either clockwise or anti-clockwise. We will not take both kind of arrangements. So that means, as I said, order is taken. Order is very much important. So because total 7 persons are there, they can be arranged in 7 minus 1 factorial. But as we are taking only one direction, either anti-clockwise or clockwise, so we will take half of it. Half into 6 factorial. 6 into 5 into 4 into 3 into 2. So when I cancel this, I have to multiply and I get 360 ways. This can happen. Let us go to question number 8. In question number 8, I will give you total R letters, and there are N post boxes. So you have to find number of ways of posting. In how many ways I can do that? Suppose I have N post boxes like this. N boxes are there. Now I am having R letters. Each letter, suppose 1, 2, 3, like this, R letters are there. If I want to put each letter, the first letter, for the first letter, N boxes are there. For the second letter also, N boxes are there. For the third letter also, N boxes are there. For rth letter also, N boxes are there. So each work can be done in N ways. Total work can be done in N power R ways. So this is how you will write. Coming to question number 9. Now imagine there are 10 candidates. A1, A2, A3, like that, A10. 10 candidates are there. Okay, they are to be ranked. You have to rank all these 10 candidates. But my condition is A1 is always above A10. That is my condition. So what is happening is, in the beginning, I will take total 10 candidates. 1 second, I will erase this. Yes. Total, I have 10 candidates. Okay, if I won't take any condition and if I arrange these 10 candidates, I can arrange in 10 factorial ways. In these 10 factorial ways, in some ways, A1 will be above A10. In some ways, A10 will be above A1. So we have to take only this case. That means half of the case will have A1 above A10. Half of the case will have A10 above A1. So you have to take out of 10 factorial, you will take only half so that we will get A1 above A10. We should not take all the 10 factorial. This is what the question demands for. Okay, let us go to question number 10. In question number 10, there are 7 men and 7 women. You have to make them sit around a table. What is the condition? If a man is sitting, on either side of him, women should sit. So now you have to find number of seating arrangements over here, depending on the condition I gave you. So what I will do, I will take the round table and first I will ask the women to sit. So total 7 women are there. We are arranging women 1, women 2, women 3, women 4, women 5, women 6, women 7. We are arranging them around the circle, and 7 women can be arranged in 7 minus 1 factorial ways. That is 6 factorial ways. But my work is not complete. I have to multiply something. Okay, now when you start arranging men, for men you can see 1, 2, 3, 4, 5, 6, 7 places are there. So for men, when you are arranging, total they have 7 places. So 7 places are there and 7 men are there. They can be arranged in 7 factorial ways. So now my work is complete. I can say total number of seating arrangement will be 6 factorial into 7 factorial. Okay, we can go to next question. Question number 11. I will give you a number 9600. You have to find number of divisors for this number, including 1 and 9600. So first of all, I will prime factorize 9600. 3 threes, 3 twos. The next 2 16s, 0 0. 2 eights, 0 0. 2 fours, 0 0. 2 twos, 0 0. 2 ones, 0 0. 2 fives and 0. 5 tens, 5 twos. So 9600 can be written as prime factorization of 1, 2, 3, 4, 5, 6, 7. Total, there are 7 twos. So I will write 2 power 7. And if you see, there is only 1 3, but there are 2 5s. So this is how I will prime factorize it. Now, if I want to find the number of divisors, I will take the power 7, 7 plus 1 into power 1, 1 plus 1 into power 2, 2 plus 1 base. Because we are including 1 and 9600 also, I need not subtract anything. Okay, so this will be 8 into 2 into 3. And that will be 48 divisors can be had. Okay. Next, we will go to the question number 12. Suppose there is a class tournament. Class tournament. Participants play one game with another, like P1 versus P2 game, P2 versus P3 game. Like this. One participant will play game with another participant. So on. Suppose if there are 2 participants, they played 3 games. After that, they fell ill. So they are removed from the tournament. Now they will not play. But I will give you total number of games played. That will be 84. My question is number of participants in the beginning. That is my question. So suppose if there are n participants, I have to find what is this n. That is my work. Very simple. Now, how will I find this work? How will I find n? So what happened is total n participants, right? Number of participants in the beginning n. Then 2 participants are removed. After removing, how many participants are left? Participant left, n minus 2. In the beginning, n participants are there. Now, n minus 2 players are there because 2 are removed. So, if from these n minus 2 participants, you select 2 participants, you can play games. You have to select 2 participants and conduct a game. Right? From n minus 2. Okay. In that way, we will count how many games. But what is given? 2 participants played 3 games. What is meant by that? Two participants are playing three games means what I'm saying here. These two participants have played three games each. That means these two participants played total 6 games. From n minus 2, you will select two participants and make them play. But already the two participants played 6 games and now total 84 games were played. So how will you find n? Start with n minus 2, take two numbers and divide by 2 factorial equal to 84 minus 6. That is 78. Or I can multiply. What I will have? N minus 2 into n minus 1 equal to 156. I have to simplify this. I will do that in the next page because I don't have place. N minus 2 into n minus 1 is equal to 156. Am I correct? Yes. Isn't it? No. Here we made a mistake. Actually, it is not n minus 2 into n minus 1. Let me correct it. Sorry. N minus 2 C2 means, I'll write in the next page. Let me rub it. N minus 2 participants which are left after removing 2 participants, we are selecting 2 from them and making them play. And already 2 participants, they played 3 games each, so 6 games they played. Total there are 84 games. So n minus 2 C2 can be written as 84 minus 6, that is 78. Now start with n minus 2. The next will be n minus 2 minus 1. N minus 3 by, because you are going to take only two numbers, by 2 factorial equal to 78. N minus 2 into n minus 3 equal to 2 into 78. And 2 into 78 will give me 156. N square minus 5n plus 6 minus 156 will give me 150 equal to 0. When you factorize it, n minus 15 into n plus 10 equal to 0. Or n I will get 15. So in the beginning, only 15 persons were doing the work. So I have completed question number 12. We will go to question number 13. As per question number 13, A and B. A and B are greatest values of 2NCR and n minus 1 CR. Then the options are A equal to 2B, B equal to 2A, A equal to B, none of these. So first of all, if you take 2NCR, 2n is even number. And there is a shortcut way to do this. If you have 2 NCR, then if it is even number, if 2n is the even number, then greatest value here will be 2n C 2n by 2. That is 2n C n. This is for even numbers at the top. So this we are taking as A in the question they have given. Similarly, if you see n minus 1 CR, what is the greatest value of it you can take? For n minus 1 CR also, we have greatest value. I think there must be a correction here. This is 2n minus 1. 2n minus 1 CR. Because we know 2n minus 1 is odd number. So if you want to select the greatest value here, the formula is, for this also there is a formula. And that is 2n C n minus 1 or 2n minus 1 C n minus 1. So the formula for this is the greatest value will be 2n minus 1 C n minus 1. These two are formulas. This I will take it as B. So I'm writing as formulas. Remember, if the top is even number, one formula. If the top is odd number, another formula. So because we have to find the relation between A and B, I will start with A by B. A is 2nCn, B is 2n minus 1 Cn minus 1. Now I gave you one formula here. I will make use of that formula, but I will write here. If you have NCR, you can write it as n by r into n minus 1 CR minus 1. This formula I will use it. Why am I using this formula? You will understand once I do it. So for numerator 2nCn, I will write 2n by n. And then I have to multiply with what as per the formula? 2n minus 1, Cn minus 1. One line extra. As per the formula, this is what I will write. Down I have 2n minus 1, Cn minus 1. So I can cancel these two and then I can cancel n and n. So I will get A by B equal to 2. Or I can write A equal to 2B. That means first option will be correct. Okay. Next we can go to question number 14. Yes, I will give you question number 14 now. Suppose n is some even number. And suppose if I give you NC0 is less than NC1 is less than NC2 is less than so on NCR, which is greater than NCR plus 1. NCR plus 1, which is greater than NCR plus 2, which is greater than so on NCN. Then R equal to, that is the question. We have to find what is R. So if you see this condition less than, greater than, this is less. slowly increasing, 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 increasing. So here it is increasing and you are reaching greatest value. After that, this is only the greatest value, because after that it is decreasing, 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 decreasing. So first the values are increasing, later on they are decreasing. That means I can write greatest value in this question is NCR. So if you want to find greatest value, that is NCR, that happens when R equal to n by 2, because n is an even number. So your option easily goes to R is equal to n by 2. Next we will go to question number 15. In question number 15, let us take 6 boys and 6 girls. We are arranging them alternatively. That too in X ways along a circle. So this is circular permutation. And again, we are arranging alternately. Again, we are arranging alternatively in Y ways. Then how X and Y are related to each other? That is the question. Okay. So here, what is happening? We are arranging 6 boys and 6 girls alternatively. That means on the circle, B1, B2, B3, B4, B5, B6 boys we have already arranged. Isn't it? So when you are arranging 6 boys, you can arrange in 6 minus 1 factorial ways. But you are supposed to arrange 6 girls also. So 1, 2, 3, 4, 5, 6. There are 6 girls and 6 places. So they can be arranged in 6 factorial ways. We are arranging 6 boys and 6 girls alternatively, and that is X ways. So we have 5 factorial into 6 factorial ways. So now in the question, we know what is X. What is X? 6 boys and 6 girls sit along a line alternatively in X ways and along a circle alternatively in Y ways. So I think I have put the question in a wrong way. So let me correct it. So what I want to tell you in question number 15 is there are 6 boys and there are 6 girls. First of all, we are arranging them in a line. Arranging in a line alternatively. That is the condition. So B1, B2, B3, B4, B5, B6. They are arranged in 6 factorial ways. Now for girls, 1, 2, 3, 4, 5, 6, 7 places are there. 7 places are there, but 6 girls are there. So they can be arranged in 7p6 ways alternatively. But if you take 7p6, that will be a problem because we are counting the first as well as last. Because you should not have that many places. There are 6 boys and 6 girls. Total 12 places only should be there. So what I mean is, if I draw 12 places, it will be clear to understand. That means in the beginning, only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6 boys, B1, B2, B3, B4, B5, B6 are arranged. They are arranged in 6 factorial ways. Now for girls, G1, G2, G3, G4, G5, G6. 6 places and 6 factorial. So girls arrangement, boys arrangement over, my work is complete. But if you see, this arrangement started with boy. Suppose there is another case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Instead of starting with boys, suppose first I will arrange all the girls, 6 girls in 6 places. That can be done in 6 factorial ways. After that, the boys can be arranged in again 6 factorial ways because there are 6 places and 6 boys. So the total, this work is also complete, this work is also complete. The total work will be 2 into 6 factorial into 6 factorial, and that is taken as x. Now coming to y. What is y? Now the boys and girls are arranged in a circle. How can you arrange? Suppose you are arranging 6 boys, B1, B2, B3, B4, B5, B6. You are arranging 6 boys means you can arrange it in 6 minus 1 factorial. After that, for girls, 1, 2, 3, 4, 5, 6 places are there and 6 girls are there. So number of ways of arranging will be 5 factorial into 6 factorial. So this is taken as y. Arranging in a line is taken as x. Arranging in a circle is taken as y. So how x and y are related? Divide x by y. What did we get for x in the previous page? 2 into 6 factorial into 6 factorial. So 2 into 6 factorial into 6 factorial. What is y? 5 factorial into 6 factorial. So 1 6 factorial will cancel. Now how can I write 2 into 6 factorial as 6 into 5 factorial by 5 factorial? 5 factorial will cancel. So there are total 12 ways. That means x by y equal to 12 or x equal to 12 into y. That's how they are related to each other. Okay, so we'll go to next question. I think we have completed 15th question. Okay, I will start 16th question now. Let us take 16th question. What shall we take about this 16th question? Suppose we have vertices of octagon. In octagon, how many vertices will be there? 8 vertices will be there. Now, with these 8 vertices, you can form triangles. But my question is, number of triangles formed with these vertices, but none of whose side is side of octagon. That you have to find. So diagrammatically, I can explain you. Suppose there is an octagon. 1, 2, 3, 4, 5, 6, 7, 8. This is octagon. So in octagon, we have total 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8. Now, out of these 8 vertices, we are going to select 3 vertices to make a triangle. So in this way, we got a triangle. But the condition, look at the condition, the number of triangles whose vertices are at the vertices of octagon, but none of whose side happen to come from the sides of octagon. See, this is the side of the triangle, this is the side of octagon also. That means this side is not acceptable. You can't take this as a side. That is what they are saying. You cannot count this triangle because one of its side is on the octagon. So my question is, number of triangles that can be formed, that you have to count. So how will you count it? Total, if you take, there are 8 vertices. Total 8 vertices. From 8 vertices, we will select 3 vertices so that they form triangle. But there are some triangles. Out of 8 vertices, if you select, out of 8 vertices, if you select, one side will be the side of the octagon. One side of the triangle will be the side of the octagon. So you have to subtract this. Is this clear? And then you have to take from 4 vertices, you have to select one vertex. Why we are doing that? Because we are also subtracting the vertices. I'll tell you. Let me be more clear. First of all, what I said, from 8 vertices, we are selecting 3 vertices to make triangles. Isn't it? But what happens is, some triangles which we are selecting, that we will minus it. From 8 triangles, if you select from the 8 vertices, if you select the case where one side of the triangle will be the side of the octagon also. That means there are some triangles isn't it? So how many triangles are there? How many triangles are there whose one side makes or coincides, or one side is same as the side of the octagon? See this side. This is the side of triangle. This is the side of octagon. We should not take such triangles. So to form such triangle, what happened? From 8 vertices, you are selecting only one vertex to form such triangles. So such triangles you have to subtract. Not only that, you have to subtract some more. What is that some more? There are some triangles for which two sides will be same. See, this side is same as the side of the octagon. This side is same as the side of the octagon. And then you are making a triangle here. So you don't need such triangles also. So how can you remove such triangles? Because now we are taking two sides. So total how many combinations? Two sides, taken two sides to make a triangle. So total four are there. Four cases are there. And in all these four cases, what will you see? You will be selecting in such a way that two sides are common. The two sides are common in these four triangles. Four triangles means 4C1 triangles. See, one triangle will be formed like this, one triangle will be formed like this, one triangle will be formed like this, one triangle will be formed like this. Four triangles are there, where two sides are same as the sides of octagon. So you have to remove that also. Finally, if you use the eight sides which they form triangle, that also cannot be calculated. So you have to remove that also. That means start with 8, 8, 7, 6, 3 numbers by 3 factorial minus 8C1 is 8, 4C1 is 4 minus 8. You can cancel this. 56 minus 32 minus 8. So 16 such triangles can be counted. This is a little bit difficult question because we have to imagine the octagon. We cannot draw all those. That is the reason. Okay, let's go to next question. The number of ways in which an examiner can assign 30 marks to 8 questions. So 30 marks you have to assign when you are making the paper to 8 questions. Now, what is the condition? But what he has to do? Giving not less than 2 marks to any question. 2 marks to any question. The question they are asking here, number of ways he can set the paper. He can set the paper. That is what you have to find out. So if you observe carefully, imagine XI marks are assigned to the question. Then what happens? For the first question, x1. For the second question, x2. For the third question, x3 marks. Like that, for the eighth question, x8. Total should be 30 marks. That is what they are saying. Now, what they are saying, each question should not have less than 2. That means this xi mark can be greater than 2 or equal to 2, but not less than 2. These xi marks, they can be greater than 2, they can be equal to 2, but not less than 2. That is the condition. Okay. So what I will do is xi minus 2 has to be greater than or equal to 0. Or this xi minus 2 I will write as yi. So in other words, yi is xi minus 2 and yi is greater than or equal to 0. So what will happen taking this? Because yi is xi minus 2, which is greater than or equal to 0, and because I have x1 plus x2 like that up to x8 equal to 30, what I will do is I will write x1 minus 2, I will write x2 minus 2, so on I will write x8 minus 2. So what is happening is I am subtracting 2. How many times I have subtracted 2? I have subtracted 8 times. So I will add 2 8 times equal to 30. So this xi minus 2, I can write y1, I can write y2, and I can write y8 equal to 30 minus 16. That is, I have 30 minus 16, I can write as 14. Isn't it? So this is an equation which I am getting here. Now, in this equation, I want total number of solutions. I am finding actually total number of solutions in one way. And what will be the total number of solutions? I have to take the number n as 14, and how many terms are there? That I will take r as 8. So the formula is n plus r minus 1 cr minus 1. That is 14 plus 8 minus 1 c8 minus 1. 22 minus 1, 21 c7. This will be there in the option, so you have to go to this option. So I think we have done enough problems today. We can go to some more problems in the next class. Be practicing problems like this. So see you in the next class.